Welcome to our new episode of Burning with Intelligence, and in this episode we will be talking about our new emissions calculator software, how it can be used, how it can calculate your emission reductions, fuel savings, and how you can optimize your burners. We've engineered this emission calculator software to be as simple as possible to enter the data, to calculate the emission reductions and the fuel savings. As compared to the old emission calculator software, this is now a single page view. So rather than flicking through one tab to another, all the data can be put into one single page now. In this latest version of the emissions calculator, we made some improvement as where the performance data has been put in. So rather than taking an average reading, now we put in the data on low, mid-fire and high-fire position with a percentage as how long this burner stands on those percentages. So in order to use this software, the typical data we need is the O2 readings, CO readings, your stack temperatures, your fuel usage and the fuel cost. The new emission calculator has been divided into 8 different sections. So anything which is yellowed out is the information which it automatically calculates. Anywhere where it's white boxes, that's where we need to put the information in. So when we look at the box 1, which is the site details, so we put in the information as which site we're getting this data from, who is the engineer who's actually taking these details. In case we need to send a quote or this emission calculator report to the client, we have this information printed on the final report. Section 2, that's where we put the ambient conditions. So are we measuring in imperial or metric units based on where you're located? Then we need the temperatures. Obviously your ambient temperatures can affect your combustion. The colder it is, the harder it is to make the savings. Warmer it is, the fuel and air mix is quite easy. So we need to know this information. Also your ambient pressures. So if you are at the sea level, then the ambient pressure will be taken as the standard 1.01. Or if you are on high altitudes, then this value will be slightly lower. In section 3, we add the fuel details. So where we're getting the fuel, what type of fuel it is, if it's liquid fuel, natural gas, or if it's a biofuel. We can also add a fuel if it's not already listed in the emission calculator. We will need the specific gravity of the fuel, we will need the calorific value and the chemical concentration of the fuel, and we can actually add a new fuel in. In section 4, we put the fuel consumption data. So this information either our engineer from the site can provide us or the end users can actually provide this information to you. We can calculate, we can get the consumption data either per hour, per day, per quarter, per month or per year. We can then add the relative currency, if it's US dollars, pounds, euros, or any other currency that you would like to add and calculate in, and then the relative cost of the fuel per unit. In this case, we're using cubic meter per hour, and the fuel data which has been given by Declan is 5,775 cubic meters per hour. Section 5 is your existing performance. This is where I will ask my friend Declan to pass on the information for a combustion audit he's just carried out at the NHS site. So Declan, if you can kindly send me the information on CO, O2, stack temperatures for the NHS site, and then I can proceed further with the emissions calculator.
Okay, so the boiler runs off natural gas. I'm going to take some readings now from the test point in the rear stack. Hey guys, readings are as followed. So at high fire, we were 6% O2. Mid fire, we were 7% O2. And low fire, 8% O2. Across the firing range, the CO was 80 ppm and the NO was 50 ppm. So real good savings to be made here. It'd be really interesting to see what our emissions calculator has to say. Over to you guys.
Thank you Declan for providing the data. I have now put this information into the existing performance and also have the averages calculated. Now we'll move on to section 6. This is where we'll put the stack details. In case you are not changing your stack, you can leave it as it is. It's quite hard to get this information from the clients, especially on a retrofit project or where you're only making the burner change. The chances of changing the stack is actually quite unlikely. So we will leave that as it is for this application. Now we need to put the data into the projected performance. This will be based on if you are simply doing a controls upgrade or if you're actually changing a complete new burner. Based on our experience from the previous case studies and the projects we've carried out, we can roughly estimate how we can optimize a particular burner. So in this particular case, we are using the readings as 6% O2 at low fire, mid fire and high fire is 5%, with CO reduction from 60 to 80 ppm. Relatively, your exhaust temperatures are being calculated as how much of a change this will make into the savings. At this section 8, we are keeping the same stack dimensions because we're not changing that. Finally, on the right hand side, we can see our savings report. In this particular case, we can see we are saving emission savings of 16.35%, which will give us another 6.4% fuel savings and overall efficiency improvement of 0.04 megawatt of this particular boiler. We can also add further savings depending on what equipment we're using. In this particular case, we're only adding the and the EGA. Exhaust gas analyzer adds further 1 to 2% of savings with the help of 3-parameter trim. Once we have calculated our savings, we can now save that into our PC. We can click on File, then go on to Save As. The reason why we're doing Save As, because it will save all this data into emission calculator file, which means if later on the client asks you to change something, they may ask you to add draft control into the report, we will be able to open up the file and add that. So we're saving this file as NHS Hospital Report. We can save that. And now, in order to generate a report in PDF that we can send it to a client, we can go on to File, Print, and simply select the Microsoft Print to PDF. Press OK. Enter the site name, which will be NHS Hospital Report, and OK. And now we have this report ready to send with a quotation to the client. Here is the PDF report that we just created from the emission calculator for the NHS site. It provides all the information we have put in. So if we flick through different pages of the report, it provides data on the site information, the ambient conditions we put in, the fuel consumption, the existing performance data, and the projected performance data. And finally, in the end, it also takes into account the formulation that we use in order to calculate this. So this is now our existing performance data, our projected performance data that we added in, and projected savings. Now this report is already created for the client to receive and use that in anywhere in their paperwork for auditing purposes. The report also provides the emission chart, which gives you two different sections, the harmful emissions and also the friendly emissions, the before and after the install data, cost and efficiency chart, so your efficiency, how it is before the upgrade and after the retrofit has been carried out. Similar view for your fuel consumption, what was the cost before and now after the retrofit has been carried out, what will be the projected fuel costs. Another feature that we have added into the emission calculator is return on investment calculation. So if we click on Tools and go on Return on Investment Calculation, for this particular project, because we are talking about only an upgrade, so investment case name, proposed upgrade, project cost. Now this can be different from based on where you're based, what the labor costs are, what are the custom clearance charges if they apply, shipping charges, etc. So based on that, the project cost can change. But for this particular example, let's say we're using £15,000 as the cost of labor, equipment, installation, and final commissioning. Once we put in the project cost, now it's taken into account our annual energy savings and also the cost savings. This is life cycle savings of over 10 years period. And based on the information we put in, simple payback period is about 0.8 year. Thanks for your time. We'll see you on the next video. Stay tuned for Burning with Intelligence.